Welcome to today's webinar entitled Creating a Ventilation Strategy to Meet Carbon Reduction and Healthy IAQ Goals. My name is Billy Zadig, Manager, Special Projects for APA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to APA's webpage later this afternoon. You'll receive a follow-up email in the next couple of days with a link to the webpage where all webinar recordings are housed, as well as a link to our upcoming webinars. We have webinars planned out through the end of 2021, and they are open for registration. Professional continuing education and AIA CLU credits are being offered for today's program. If you're an AIA professional requiring a certificate, please send an email to me at Billie, B-I-L-L-I-E, @apa.org, along with your AIA membership number if you've not done so in the past. All attendees are in listen-only mode. Please type your questions in the chat box and they will be answered in the order they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by one of our presenters. If you are just calling in, make sure you send an email to me at billie@apa.org so I can send you a certificate if you requested one. The system only recognizes you if you log in. At this time, it's my pleasure to turn this over to Sarah Callahan, who will introduce our speakers for today. I will rejoin you for the Q&A session later. Sarah, take it away.
Hi and welcome. Thanks to everyone for joining us. Today we have Dan Deal, who's the CEO and President of Acuity, and we've also got joining us Zach Cook with Utah State University. He is the Senior Energy Utilities Manager there. And starting us off today is Dan.
Thanks, Sarah. Thanks for having us on today. I'm warm up back here. For Zach, the keynote speaker, but I'm really excited to share some of what we're seeing happening in the world today. And I actually really think it's super exciting for all those that work in the built environment for, well, many of you for a long time, like me. It's a really dynamic and rapidly changing environment out there, and certainly COVID has had a significant effect on that. But as we're going to talk about very interestingly, also getting building and the built environment to net zero is becoming a primary driver. So I think there's really good content here to talk about that we'll share further with you. So we'll talk about what's happening, these kind of mega trends, getting the built environment to net zero. How do we do that while also providing and optimizing health and cognitive function for all the types of buildings that we occupy and work in? What does tackling ventilation mean to that effort, and how do we do that over the life of a building accurately and effectively? What has COVID taught us? And we'll talk about actual case studies, and we'll get to a real good actual case study from Utah with Utah State with Zach, and then we'll talk about just briefly at the end there a roadmap for success. So what's happening? Sustainability and carbon reduction actually over the last even 6 months has taken a pretty significant turn. We're seeing a lot of customers, and ESG, if you're not familiar with it, is environmental, social, and governance. And there's been increased pressure from the investment community and boards and the C-suite, if you will, from higher ed to life sciences, and even in municipal governments to really get the built environment to net zero and to get it much more energy efficient. And obviously a lot of that is being driven by the climate crisis. And there's also some things you see over here on the right, a lot more what I call carrots and sticks out there in terms of actual penalties being punitive. They're looming in certain major cities, and they're starting to spread to many other cities. We're also seeing on the positive side many utility rebate incentive programs, and we're also going to have a cost of carbon. So what is really effectively changing the built environment, and I see this happening across the country, is people getting serious and making investments and really putting plans that they're going to further support and really take initiative on in terms of energy efficiency and carbon reduction. With that being said, obviously air quality and what happened with COVID is air quality requirements across all these environments is something that's becoming really a must-have, not a nice-to-have. And managing ventilation is now the largest kind of untapped efficiency opportunity in much of the built environment since lighting has gotten so low. So it's the next big opportunity for us to tackle. And at the same time, we have to do it in a way that's also very efficient, both in energy spend, but also in effectiveness. And then the workplaces are changing. So we're going to see less densely occupied spaces, much more highly variable occupancy, and that's going to drive the need for more flexible and more intelligent environments. And some of the other points here, we're seeing a boom in research and life sciences. Actually, having been around in the 90s when that was a really hot market and a place, we're seeing new research space being premium and being developed all over the world, and also everyone trying to tackle those environments because they are the most energy intensive spaces in most customers' portfolios. And then lastly, when it comes to healthcare, we've all seen on the news that healthcare can't be part of the problem, so to speak, in terms of being a safe place to work and to go to. So major investments in research going on and how to continue to improve those environments. So these trends really support the rest of what we're going to see and talk about in this presentation today. And what all that looks like, in a very kind of more condensed format is really a requirement for better workplace outcomes in terms of health and productivity and wellness, plus being able to do that in a net zero, ESG carbon neutral environment, and then to an emergence of bringing new technology and adopting it to the built environment is going to meet the requirement of healthy and sustainable buildings, schools, and workplaces, and research spaces as well, because all of them are just as equally important and focused on this. So what does this look like in action? This is going to drive, and it already is starting to drive, a significant transformation in the built environment. And the one thing I think it's most akin to is probably electrification of cars, that you can point to it and say, okay, well, there was a report about 3 or 4 years ago that the combustion engine was going to be around till 2085. And the most recent report is that will be gone completely in the mid 2030s. And you're seeing, obviously, on marketing and on the road and everything else, that transformation happened much more rapidly. And I think the same thing is going to be happening to the built environment. Net zero is going to become a requirement, and we're going to have to do that through adapting these new technologies. I remain extremely bullish on this front, really positive. Because we personally have been involved in dozens of net zero projects around the world, and we've seen these buildings operate for a long period of time and do so very successfully. So we know the technology is there, we know the engineering and ability to do this is there, and it's really just about much more wide adoption of these proven concepts and proven technologies. And I did the last bullet here is you just really need to do this and make these buildings reliable over the life of the building. As we know, buildings don't go anywhere. They're often there for 50 to 80 years, and we can't allow deferred maintenance with these new technologies to be acceptable if they're also going to provide the health and wellness that they're now being required to. So a couple of these concepts, like what is it about net zero? Well, it's actually over, if you include embedded carbon with the materials and such, it's in the mid-30s% of all emissions are resulted, but 28% of them are just from the operations of buildings. So the world, meaning government, independent organizations, all sorts of different bodies and entities are looking at the built environment as a major contributor to carbon emissions and something that absolutely has to be tackled. HVAC and ventilation, as I said earlier, make up the vast majority of this. You're heating, you're cooling, and you're moving air through buildings. And if it's 100% outside air environment like a lab or an OR, that can be as high as 60 to 70% of the total energy usage, depending on that building type. And one of the best results from managing ventilation more effectively is the mitigation of reheat. And when we are involved in many retrofit projects where we see reheat almost completely go away, again, because you're not overcooling a space, supplying 55-degree, let's say, supply air, and then trying to reheat it back up for temperature. When you reduce the volume of air and manage it more effectively, you can really eliminate almost, not always entirely, but you can dramatically decrease the amount of reheat that's used in these buildings. And that's going to be a key engineered, benefit and solution as you go to net zero, because you always have to fix the energy efficiency of the built environment before you go and then try to size your supply and your renewable sources. We've showed and proved to some customers that we've saved them, tens of millions of dollars in solar by dramatically reducing the energy usage in their building. So these two things go hand in hand, and it's extremely important to look at them as a total system and not just as an individual, ECM or facility improvement measure. And then lastly, again, these building occupancies, ventilation is going to be critical to be managed because occupancies are going to be much more variable with this hybrid work world that we're seemingly, migrating to, and in some industries is going to be a little bit, here to stay. So this is a must-solve challenge for us in this industry. And it's why I started out by saying I think it's a really exciting time. I think it's going to be a lot of work to do, and I think we should all feel really good about trying to tackle these new challenges. And hopefully, because of the ESG pressures, more of our organizations will put the proper resources to doing this and tackling these challenges. As I mentioned, energy efficiency is a core component of net zero buildings. And this is from the New Buildings Institute, but you can see it really talks about maximizing energy efficient first and foremost, prioritizing your on-site renewables, utilizing off-site renewables, and then also measure and manage to net zero operations. Again, this concept of making buildings more intelligent, smarter, so that they the systems can be maintained reliably over that life of the building, and you can get the results of a healthy and safe environment. So this is, I think, again, to leave that concept, net zero is going to be an ongoing, a very important concept. And moving over to the health of the environment, if you haven't seen this, the World Health Organization just published this. We've got connections to this on our website. It's being talked about a lot more, and really the point of this whole next couple of slides is, the COG effect studies were originally focused on CO2, and obviously the carbon reduction movement is about reducing carbon. But we're also now really seeing, both from COVID and also this report, that small particles, it has a major impact in our health, and it's a very, very pervasive problem, both outdoor environment and the indoor environment, that needs to be measured and managed more effectively going forward. Very happy to see WHO and also other organizations like IWBI really get standards in place about what does good indoor air quality look like, what level of small particles, and this is 2.5. I mean, we measure all the way down to 0.3 microns of particles, which is comes from our kind of research space background, and they are the particles that both COVID and other things can latch onto, and they can actually go deep into your lungs and bypass your typical immune defense, your human defense systems. And particles is becoming much more important, but you also see on here, TVOCs and these other harmful gases needs to also be considered. Buildings are being cleaned more often. We all need to be making sure that our buildings are healthy, not just from a particle perspective and a CO2 perspective, but also from a harmful gases standpoint. And this cost is real, and this is what is driving this movement. I mean, I think we all know this now intuitively with what just happened with COVID, but when these buildings are part of the problem and not solution, they're not safe places to go, the cost is absolutely astronomical to the economy and to the organizations that we all kind of live and work in. So with that, this is a saying we have, but I think it's just as a truism in life and good engineering. You can't manage what you don't accurately measure. And I think it's an important concept that we want to really get across. I mean, it's always been a challenge in the built environment, especially when it comes to some of the things we're talking about, TVOCs or particulates as an example, aren't traditional measurements that are done very well with, in the building automation industry. Stuff that we have been doing for quite a long time. You're also seeing a lot of our customers are finding this. The outdoor air conditions are changing, unfortunately, right before our eyes. We all witnessed the fire in Europe, the fires in Australia. Seems like 1 or 2 a year now on the West Coast. And actually, a lot of those are now spreading across the country. We had customers in the Midwest and even on the East Coast calling, asking about particular measurements outside that went up through a huge spike, and it was from fires all the way out in Washington State. So we're seeing really, more customers wanting to understand what air they're actually bringing in, and then how effective are their air handling units and filtration strategies and maybe other air cleaning strategies that they might be deploying. How effectively are those working? And if you don't accurately measure that, you don't know where your baseline is. You don't know how effectively you're doing that. And the last part of this is, and this is kind of an emerging and evolving field, and it's something that we've experienced quite a bit over our history is, when you look at indoor air quality, it goes well beyond facilities typically. We have environmental health and safety, infectious control, animal care professionals, we have researchers themselves, we have PIs, principal investigators, all sorts of people wanting to understand and look at and get access to air quality data. And many times they want easier, more digestible data and analytics for what they're concerned about. What was the level of particles in this space? How long did it last? Did it get cleaned out? All those kind of things. And so we try to provide that. So you're seeing more air quality data more pervasively displayed and utilized in the built environment. So I'll go quickly through this. I mean, if you don't, we have a lot of information on our website. This is the commercial part of the presentation, but been at Aircuity for a long time. I came here because I believe in the concept, having come from other, the building automation industry. The idea was to, accurately measure indoor air quality and dynamically control ventilation to optimize both the energy efficiency and the health and wellness and safety. And it's often misconstrued that, most times we're actually providing more air where and when needed when there's an event. So it beats, kind of what we always say, it beats a prescriptive approach because you're getting more efficient when you don't need all that air, and you're getting much better safety and performance of the system when you actually do need it. And you also get all the analytics from the system that can help you from a fault detection diagnostics fix problems much more quickly, much more accurately. So the platform comes, it measures carbon dioxide, dew point, TVOCs, total volatile organic compounds. And we do that actually through two methods. One, which is a much more of an industrial grade approach in a photoionization detector. We look at particulates, large and small, and we go all the way down to that 0.3, and we're going to be improving even on that in the coming year. And then obviously carbon monoxide as well. And the platform looks like this. It's a multiplex sampling platform. What you should know is that this allows us to do this very accurately, very cost effectively over the life of the building. If you look at a life cycle cost approach, this is going to win hands down if you are comparing it to calibrating and maintaining those types of sensors out in your space, which most people, can't effectively do over time. And so this is a life cycle cost solution approach. And then we actually take that data, report it to the cloud for, repurposing to all those constituents I said earlier, and we also integrate that to the building automation system for dynamic control. So the lessons we've learned are, particulates are very important. This is a slide from Dr. Stephanie Taylor, who's a distinguished Ashrae lecturer. You may have had her on a previous, I'm sure she spoke at APA previously at maybe local regionals, and incredible presenter and a lot of data and experience in the effects of humidity and what happens to the small particles and how long they last in the air at different humidity levels, and why it's so important to mitigate the amount of them in the space. And what you find typically is that in this 40 to 60 range, which I think is actually her website, it's called 40 to 60 RH. You see how much healthier and effective the environment, the built environment is. Now, I'd say that kind of knowing full well, like many of you do on this presentation, that humidity is one of the most challenging things to control and manage in the built environment. So I think with this knowledge it's really about knowing. We're not drawing a line in the sand saying you must maintain these levels and go to great expense to do so. It's really about knowing this dynamic and how do we begin to change control strategies, balance occupancy levels, all sorts of things that we're talking to customers about when you may have extreme dry times, periods like in the winter, and or high infection times or periods. So this is just RH and particulates are certainly a big part of what we learned from the whole COVID experience. The other thing we learned was filtration effectiveness is absolutely important. And Ashrae and most our customers have gone to increase to MERV 13 and or above. And one of the benefits that you also then want to think about dynamically controlling ventilation is you increase filtration, you obviously also affect your differential, your pressure. And so therefore, to make that as efficient as possible, you want to, in some cases, you're balancing that increased pressure with demand control ventilation and still getting a much more efficient system overall while getting that much better filtration effectiveness. And for a lot of customers that we've seen earlier, I didn't show you the video earlier, but for a lot of our customers, we're also doing this particulate measurement where we actually, all air acuity systems have an outside air reference that because we do differential measurement, we compare that to the supply air, the room air, etc. So we really want to know what's coming in the building. We want to see if they have a return air. We want to see what's coming back. And then we want to see how effective that supply air is looking. And this is really where you can't, again, if you're accurately measuring this, you'll really know how effective your system's working. Is there filter bypass? Did you get a massive improvement when you upgraded filters? Can you change your filters based on actual performance versus, time-based? We've got customers doing all of the above. And so again, it's really important to do this in the sense of we see a lot of projects and examples of data where somebody might be bringing, you see a spike in a room, but you might be bringing that in through your actual system, through the supply air. And so, do you want to increase ventilation when the problem is actually in the outside air? And it's a very good reason of establishing a system and a control strategy that Air Acuity implements, which is really identifying where these problems exist and controlling for that. So, and that's where we build in intelligent feedback and alerts for customers. So the challenges that that remain for us is relative humidity is going to continue to be interesting and going to have to evolve to where we can more cost effectively and better control to that. Are these other air quality improvement strategies and technologies that we're going to be deploying working? When and where do we provide more ventilation? And how effective is everything we're doing from a strategy perspective to provide healthy, safe working environments actually working? And the last point on this slide is something we've been saying for 2 years now, which is coming from the critical environment spaces. Again, we know the strategies that work, and we know that we can do both really energy efficient and much safer environments. Really interesting, one of our clients, University of California, Irvine, we're going to talk about in a second, has just reported that they have almost by twofold the lowest health safety incidents in the entire UC system. And they've been implementing smart labs for over 13 years. And by education, it's not just like an let's say quote unquote an air acuity thing or managing ventilation. It's really about a cultural effort to want to know the data, want to understand how the systems are performing, implementing these technologies, watching them work for a long period of time, and having incredible, obviously, energy performance characteristics, but also the impact and the cost benefit for the health and safety is absolutely off the charts for them. So if we begin to think about all spaces in critical environments and implement these technologies, it can be done and done cost effectively, and actually be done in a net zero environment to provide, all the way go right down to healthy and safe schools for our kids. So UCI is a great case study. They set out to reduce their energy by 50% across 17 lab buildings. They actually achieved 61% energy reduction, and they've estimated the total savings to the campus to be over $100 million over the life of this period. That's not energy only cost. That's energy, diversity savings, sizing of equipment. They totalized all of the gains that they've got from this Smart Labs program. They were honored by DOE, and they've since educated probably 500 to 1,000 customers around the globe on what they've been able to accomplish there. And Phil, I was there at day one and feel very privileged to have watched that success story. Apple World Headquarters, the project we're involved in, 3 million square feet, dynamic ventilation, near net zero building, very complex ventilation strategy. You can actually see it. There's a kind of a ring at the top of that building going around. If you look right, there, kind of going around the building. And so when you see that project, let's see, get out of that slide here. Yeah. Oh boy. Click on it again. Until we can't get out. Yeah. Okay, so sorry about that. So looking across the aesthetics were important to them, and security of the system. They can actually calibrate and maintain over 1,250 sensors all down in the basement, and they can do all that in about 2 to 4 day time frame. So it's an incredible efficiency gain across this building. And when they compare their alternatives, kind of we won hands down. When you look at Memorial Sloan Kettering Cancer Center here, this is the Zuckerman building. This was a benefit of leveraging utility incentives. This won the Energy Project of the Year. IAQ is a very important part of their program, and they leveraged ventilation. Let's just talk about ventilation management across all their different types of medical research, ORs, patient centers, and animal research facilities. And in the end of the day, they also look at that example I was giving you earlier about carefully looking at outside air particles, because they are in New York City and it can be higher there, and how effective their filtration is actually working, and are they managing to the levels they want to. This particular project was well under 2-year payback, and one of the cornerstones of all these projects that hopefully it resonates with everyone on this call, is that this customer was able to take a project that had a really good rate of return, also get a new control system, a new exhaust fan, rebalance the building, and also recommission all the systems in the building, all at turned into about a $7.2 million project, well under 2-year payback, and in this case, a very significant utility rebate incentive. What's incredible is that it resulted in a 2 megawatt reduction across this building. And that's why, obviously, you can see that the significant Memorial Sloan Kettering has done all ventilation management across their whole entire campus. And so far, you may say, okay, well, it works great at UCI, and it's okay. I see Apple. You may say, oh, well, they've got a lot of money. I'll say this, but trust me, every customer is just as concerned with cost and savings as the next. And it actually, we probably have hundreds of school districts across the country now, and most of those are kind of leaning towards K through 12 net zero. And so this is a really good example of 2 schools. One's net zero and the other is near net zero. And tremendous results, and you're seeing more and more of this work. I will highlight, because we are Apple, you can get a little more technical. I'll highlight that a lot of the schools are utilizing DOAS as well, so dedicated outside air handling systems. and many times they're coupling that with you know, a BFR system, and you know, it's a different design concept for a healthier, more energy efficient school. And so a lot of names on the board here, a lot of different building types, proven, you know, very confident in terms of proven. Acute is proven well over a decade, and lots of good case studies if you're ever looking for them. As you look to a path of net zero, and what I think the takeaway should be, again, as buildings become to be more electrified, you know, net zero doesn't necessarily directly mean electric buildings. But I just came back from an I2SL meeting 2 weeks ago, and more than 50% of the architect and engineering programs, way more, we're talking about net zero and the movement towards electrification of buildings. And if they're not deploying it today, they are believing that they're going to have to do it in the next, you know, 5 or so years, 5 or 10 years. And this is a really good roadmap as it looks into, you know, it all starts with getting buildings as energy efficient as possible, because that's going to reduce cost all the way down this strategy matrix, and provide significant offset for supply side strategies as clean energy. So I'm going to turn this over to Zach. He's the keynote speaker, as I mentioned, and it's a real case study. So I think you're going to find it incredibly compelling, as many of our customers have done, and I think hopefully you'll see more of in the next presentation. It's about committing, you know, and identifying an opportunity or a project, and most importantly, assessing the macro opportunity. A lot of times it takes higher buy-in from the C-suite and above. And when you start to look at the total impact for health, wellness, efficiency, you know, everything that people are trying to accomplish, it garners the attention of senior leadership in your organizations, and it's a well worth it, even I guess, you know, societally, of what we're trying to solve. The other benefit is you can typically address a lot of deferred maintenance when you execute these projects and these plans, these programs, as we call them. And you know, you want to leverage utility incentives where possible if you have them, and you also want to, you know, leverage the use of very low cost of capital today and other air quality as a service programs where you don't have to have capital outlay if that is a problem. You can do all this at kind of no upfront cost, and even make it a positive cash flow program. So, you know, then you implement a project and you communicate that success, and you rinse and repeat, and that's what, you know, University of Pennsylvania is now in 30 buildings and going, and UCI explained to you they're up to close to 23 or 24. It's what these customers do. They have a really good strategy, and they really get after executing it. So with that, I thank you very much. Hope shared some good insight, and I think the real success story is going to be shown next year from Zach, so I will turn it over to him.
All right, thank you, Dan. I'm excited to be here today and be able to share some of the things that we're working on and some of our efforts. Just maybe to give a little background on our university and some of the efforts that have been underway. We've been committed to becoming carbon neutral since 2007, so about 14 years or so. And you know, it's been interesting because I've been working for the university about 10 to 11 of those years, and over the last several years I've seen a dramatic and noticeable difference in the interest from faculty and from staff, and we're seeing a lot more urgency. In 2019, our faculty senate passed a resolution that challenges the university to increase the rate at which we become carbon neutral. And we have a lot of you know, obstacles to overcome, but one of those is that our campus continues to grow. We continue to have more students, more buildings, but we have seen substantial improvements. We've reduced emissions by 20% per full-time student, and 30% reduction by per square foot. So we are seeing a lot of great, you know, reductions, but it is an obstacle, and I'm sure everyone that's on this call is kind of facing the same challenges. But as we look at this pie chart, this kind of gives a breakdown of where the university's carbon emissions are coming from. And 26% are tied to transportation, whether it's directly funded transportation to the university or faculty, staff, and student commuting. But the biggest chunk, which obviously as a facilities organization we are most focused on, is this 63% that's tied to buildings that we operate and maintain. These are emissions connected to, the costs of heating and cooling, ventilating, emergency generator, diesel fuel, all of those things. And so we have a substantial part in this challenge that we are working to overcome. But obviously the buildings are our focus and are the biggest thing that we can do as a facilities organization to, as Dan talked about, focus on energy efficiency. I'm sure many on the webinar here are doing similar things or have probably maybe completed these tasks, but the strategies that we've been focusing on are, obviously developing more renewable energy resources. And a big challenge that we have on our campus is our central energy plant that's heavily dependent on natural gas, gas turbine and steam distribution. But we're working on transportation, carbon offsets, and just educating students and faculty and staff as well, and make sure that they understand their responsibility in this effort. But we've just are on the final phase of completing a campus-wide, and I will mention that we are a land grant institution, and so we have campuses across the state of Utah, and we are finishing up a conversion of all of our campuses and buildings to LED. We're on the tail end of that. Last I checked, we had replaced about 150,000 4-foot LED, or T8s, excuse me. But obviously we're most interested today in our discussion on building energy and operational efficiencies that can be gained through how we operate our buildings. On the left here, I've shown the typical EUIs of about a dozen of our laboratory buildings, and on the right you'll see the EUIs for a typical office or classroom building. And I was going to emphasize, I put this in here intentionally because I thought this was interesting as I was going through the data, but this building 56 is a classroom and office building. It is vintage 1968 mechanical system, and it's a constant volume reheat. And I thought that was interesting just to highlight to the group the comment in particular that Dan had made about the cost of reheat. And you can see it just in that building alone. But then as you start looking at our laboratory buildings that range in an EUI from anywhere between 100 to 300 kBTU per square feet. And a lot of that's dependent on the ratio of office space in those buildings to laboratory space. But they are a significant portion of our energy use. And as energy managers, there's so much opportunity. Small changes that we make in the operation of these buildings can have a substantial impact, and sometimes that's good and bad. We can make changes that have negative impacts as well. But where these systems run 24/7, 365 days a year, there's just a lot of energy that's used, as we all know. And so we've really been focused on coming up with strategies and ways that we can improve their efficiencies. In the past, we looked at trying to make sure that the runaround heat recovery loops are working properly, but really these are only gains of small numbers, because the efficiency of a runaround loop, if it's running properly, is only 40%, and you can't recapture that fan energy that's used to move the air through the building. And so other efforts in our laboratory buildings have been working with our environmental health and safety office. They've allowed in only certain labs that we can use occupancy sensors and reduce air changes down to 4. And that's typically in teaching labs. And so it's not a very high quantity of labs that we've been able to do that. The next efforts to bring these laboratory EUIs down and work towards these net zero buildings is, evaluating. We often get some non-lab spaces that are connected to lab single pass systems, and when these systems get set up, the controls contractors, they put the minimum ventilation for a VAV box at 20 to 30%, and when you have that works fine, and that's probably proper for a mixed air system, but when you have 100% outside air, that's not required by Ashrae 62. And so we've spent a lot of time making sure that those ventilation rates are proper, and often are able to set in office spaces that are tied to 100% outside air unit down to the minimum VAV controllable flow rate. And other strategies have been looking at the exhaust air and trying to reduce fan energy associated with bypass air to get stack velocities up to the 3,000 feet per minute that are required by NCZ 9.3. So that's kind of where we got to, and we just felt like we were not getting to the real root energy usage. I think as Dan talked, we see how much energy is involved with these 100% outside air units, and there's a prescribed method of 6 to 8 to 12 air changes an hour depending on what type of lab it is. And we have always suspected and figured that we were probably over ventilating these spaces, but we didn't have any extensive data to show that. And if we did have any data, it would be a static, single snapshot in time, and we really couldn't justify or say that, we saw safe air quality for this period of time, and under all scenarios it would be safe if we lowered the air changes. And so we were fortunate enough to receive a grant from Edwards Mother Earth Foundation, and it helped us put together a pilot project where we initially had planned to put the air acuity system in an existing laboratory building, our College of Agriculture, and a building that was being constructed, or a substantial remodel, in our Biology and Natural Resources building. But we were fortunate enough to be able to have funding to provide an installation in a third building, our Life Sciences. And so altogether, we are monitoring about 56,000 square feet of lab space. And we are, let me see here, excuse me. We're excited to show this data that we've been gathering. This is just a sample. The system has been installed in 2 of our buildings for about three months, and for the first 2 months or so, we were gathering just baseline data. And I've captured data from the previous month, and this, I will say, is a snapshot of since we've started doing the dynamic reset variable air change rates. And you can see this is actually one of the few labs that we actually had an air quality event, and there's just a few points in time to where that really gets to a concerning point, and those times were for under 15 minutes. And I wanted to point out, Dan mentioned this in his comments there, that there's we're monitoring the outside air, the incoming air, as well as the exhaust air from the labs. And you can see a substantial portion of the time, there is not a large difference between the TVOCs coming in versus what's in the space, other than these few moments here. And so we are seeing a large opportunity, and have been resetting and reducing the air change rates based on what's actually going on in the labs. And it has confirmed what we had suspected was taking place, that we were providing a lot of ventilation in these spaces that didn't have, if they had proper lab safety procedures, really should have good air quality. And we were, probably excessive in how much air, but where you don't know what's going on in the space, or someone has a spill. And our EH&S group, Environmental Health and Safety, has been really supportive and is excited to have access to this data. And we're looking forward to working with them as we, move forward and optimize how the system's currently currently operating. But I'll go through here and show the data that we're receiving. And again, this is just from one of the labs that had an event. 95% of the labs didn't even have any of these events and were well below the threshold. And so we're seeing some substantial reduction in air change rates that we're able to properly ventilate these spaces and effectively save a significant amount of energy. So here's the TVOCs, and again, you can see the few short spikes that we have in the VOCs in that lab. And moving over to CO2, these labs are not highly occupied spaces, and so you can see that the CO2 levels are in line with what the outside air is. And lastly, the PM 2.5, it tracks the outside air, and I'm sure with the air quality that we had this year from the fires in California, that was a big part of why we're seeing those PM 2.5. But we are very excited about the results that we're seeing. We're based on the preliminary data that we're seeing, we anticipate about a $90,000 to $100,000 savings just between these two buildings. The third building we're still gathering baseline data for, but for our College of Agriculture and Biology and Natural Resources building, we're seeing $100,000 of savings is what we anticipate based on our local utility rates and our central energy, chilled water and steam rates. And yeah, this will effectively be a 4-year payback, and that's not taking into account that we were fortunate enough to receive a grant, and that factors in the maintenance contract that we have in place to make sure that the sensors are properly recalibrated. And so the thing that we really see this being a big part of our strategy going forward is to reduce carbon emissions from the university. Is this project is anticipated and looks like it will save roughly 300 to 400 metric tons of CO2 for these 3 buildings. And as we carry that forward, our hope is that we can expand that to the other 400,000 to 500,000 square feet of labs that we operate and maintain in our in the buildings that we are responsible for. That this will be a potentially 5,000 to 7,000 metric ton reduction, which equates to somewhere around 7 to 9% of our carbon that the university emits. And so we are very excited to gather the data over this next year, and would love to have an opportunity to present as we have more data. But going forward, we are already working with our EH&S to get them access to the my Aircuity system, so they can monitor and track the air quality and see the levels at which the different labs are at. We also are anxious to start looking at monitoring the exhaust system, and so we can potentially use the concentration of any chemicals in the exhaust stream to adjust and reduce the exhaust stack velocity. And lastly, once we have a good case study, which we are starting to develop right now, we'll take this to the university's administration and try to expand this to other existing buildings on campus, and to develop a standard that new laboratory buildings are built with an air monitoring system, so that we can provide the ventilation that we need. Because with these laboratory buildings, there's not an easy way to have them be net zero. And the only way that I see that's possible is by only ventilating the spaces according to the needs. And like Dan had mentioned, it makes our environmental health and safety group feel a lot better knowing that if there is a spill, we're not limited to 6 air changes an hour or 8 air changes an hour. The system can provide higher ventilation rates for that short period of time to ensure safety for students and researchers. And so we're, again, looking forward to the upcoming year to have a full year's worth of data that we could present and share with others. And I guess at this point, we'll turn the time over to Billy to handle questions.
Okay, thank you. We have a few questions in the queue. Our first question is, does the savings include productivity gains? And to further that, it says productivity and wellness can certainly be tied together. My interest in asking is percentage of total.
So if this question is directed to USU specifically, we have not factored in any productivity gains. This is strictly on energy cost basis.
And this is Dan. If I can further answer, the cog effect study that was originally done by the Harvard School of Public Health estimates between 5 and 8% in productivity gains with management of CO2 levels in this particular study. And the well building initiative also kind of gives more points to controlling to much lower CO2 levels. It's always been difficult for clients to buy off of productivity, right? Or a CFO to buy off of productivity. But what I think is incredibly important is even if you look at 1% productivity gain, if you follow the JLL 330-300 rule, where 3% of the total cost for an organization is energy, 30% is the real estate, and the 300 is the cost of the people. So if you look at a 1% gain in productivity, it typically equates to the entire energy budget, and that's always like this kind of amazing takeaway that they kind of foundationally, got into the minds of everybody in the built environment. And so I know as energy engineers, we've really looked to tackle that, but I think the question raises an incredibly important point in regards to we have to start looking at that impact, the economic and the benefit of the health and wellness. And that is why this is garnering a lot more attention for these universities. And it's why we tried to say, you're trying to optimize both. You're not trying to balance both, because that sounds like sacrifice on either side. We need to get these buildings net zero, and we also need to provide them as healthy and as safe as absolutely possible. And again, these stories show that it can be done. So I think it's a really great question and a great point that was raised there.
Okay, thank you. Our next question is, how can facility managers measure if they are meeting Ashrae ventilation standards for acute events like pandemic or fire?
So is this is Dan from Acute, and if that question is when Ashrae was talking about going full on ventilation during a pandemic, again, that's very individual control strategy. We had many customers saying that was absolutely impossible for them to do, and that recommendation was not only unsustainable but unachievable, certainly during certain times of the year, depending upon where you are in the country, et cetera. So not necessarily commenting on that suggestion, but I do think during pandemic you will see particular organizations develop newer control strategies. So i.e. over-ventilating and maybe sacrificing some energy efficiency for what they deem to be a healthier environment. What I think, what I will add to that though is, in many cases, just like these lab examples are showing, you don't need to do that to provide a healthy and safe space. If you're measuring the important parameters and you're controlling to them and you know where they are, you don't need to solve that problem through a prescriptive overventilation approach. You know that you are managing your facility and you're providing good indoor air quality. And so we had many customers say, nope, we're good. We know our air quality, we're fine. We're going to keep doing what we're doing. So again, personal, my language is, you want to be able to do this with a data-driven approach. And I think that's what Zach's presentation did such a good job. If you have the data, you can be much more flexible and much more strategic in your various control strategies.
Okay, thank you. Our next question is, does this system control humidity, either from the outside air or inside air?
Zach, if it's related to the air acuity system, the answer is no. We provide a very accurate, reliable measurement of humidity if you include the dew point sensor, and we actually measure dew point, not RH. You would couple that with a temperature to calculate RH. Dew point tends to be a little bit more accurate and reliable, and it's, I think, a better measure. But regardless of dew point relative humidity measurement, we measure it and we provide that control input to the building automation or lab control system. We don't actually do the physical control. So the answer is, a hard no in terms of air acuity doing relative humidity control. We just provide accurate measurement. It provides accurate measurement, the platform.
And just to add on to that, yeah, we aren't doing anything with humidity in Utah. We welcome the humidity a lot of times. So.
Try. Yeah.
Okay, this question is directed to Zach. Does USU have a cost per ton of carbon? If yes, is it a material part of the overall savings in your labs?
So that is a question that we are working through right now. We had a executive council go through and evaluate and look at the cost of carbon, which they had preliminarily costed out at about 40 tons or $40 per ton, but that has not been even factored into the savings at all. And so, this is strictly the savings that we have preliminarily looked at are just savings from energy. And so I think as you factor in the carbon cost savings, it would make the project even look, even better.
Okay. Our next question is there an air filter rating that will remove the COVID virus?
Zach, do you have an answer, or do you want me to tackle
Well, yeah, this is just, I think the only, the HEPA filter is essentially the highest rating filter, and it's the best chance that you have of filtering it. But most fan systems aren't capable of overcoming the static pressures associated with the static pressure losses associated with the HEPA filter. And so here at Utah State, we've done, just as Dan had mentioned, MERV 13 was kind of the recommendation and provided the best filtration with the least implications as far as pressure drop across the filter. A lot of folks had really pushed for MERV 13 on some systems that are constant volume, that don't have the ability to speed a fan up, and we really felt strongly that it's more important to get more ventilation to the space. And so there were areas that we didn't feel like MERV 13 were suitable, but in all areas, that's kind of what we have standardized on here at Utah State. It's MERV 13.
Okay, we have time for a couple more questions. It looks like we're not going to have time to get through all of our questions. So once again, I just wanted to let everybody know that if we don't get to your question during the session, that one of the presenters will reach out to you directly to answer your question. So our next question is, one of the earliest slides showed a cost of $187,000 to install the system. Is that the total cost?
Zach, was that on one of your slides?
Yeah, I didn't remember having that in the slide. I can roughly answer that, Dan, unless you want to take that one.
No, you don't. Go ahead. Absolutely.
Yeah. So, and as I'll point out before I say this, we did 3 systems on our campus, and the rough costs were around each system was around $100,000 to $120,000 per system. But keep in mind that's in Logan, Utah, labor rates are quite different. And so I hate to say specific numbers, but that was the installed cost, material costs, and startup. And Dan, if I misspoke or spoke out of line, don't hesitate to correct me.
No, I'm very happy that you did that, because I think you answered exactly correctly. There's quite a range. That's a great example of I don't want to say like maybe slightly below average nationally for a total system. That system can do up to 29 lab zones, because we always measure outside air. What that would mean is, in New York or in Boston or in LA, you're going to see higher total installed price because of the labor rates that Zach just spoke about. So on average, I'd say if you had to have an average, it's in that 140 to 150,000 total installed cost range, and it's usually going to be an average of 2 to 3 year simple payback just on energy alone. That would be that's what we kind of broadcast nationally, and you get a pretty good disparity on both sides depending upon where you're at.
Okay, well, we're at the top of the hour, so I would like to thank Dan and Zach for our presentation today. And as always, to our attendees, thank you so much for taking time out of your busy schedule to be with us today. So until next time, be safe, stay healthy, and be kind to one another. Have a wonderful day. Bye-bye now.
Bye, thank you.